Good morning, everyone. Good afternoon, good evening, depending on where you are. I will be hosting this webinar today. My name is Daniel Virasamy. I'm a principal cloud solutions architect working for Mirantis for about 5 years now. I live in Paris. Always been very, very fond of open source and open source projects. Worked a lot in Linux, OpenStack, and more recently Kubernetes. As I always say, curious by nature, but I'm open source by choice. So today we'll be talking about modernization for cloud mobility and how to achieve cheaper and flexible multi-cloud. So what do we have on the agenda today? As I said, as it is going to be a summary of the various sessions I did during this 2023 year, basically I'm going to talk a little bit about why multi-cloud or hybrid cloud is important. We're also going to look at the foundation of building multi-cloud with open source solutions. And ultimately, we'll be talking about applications, not only legacy, but also modern applications. Okay. So why talk about cloud mobility? And I think these were discussed in webinars related to public clouds. And I used this this meme in this webinar, right? And I know that when we talk about public clouds, one of the elements that I'm getting more and more from the customers I interact with is that cost is definitely something that is a concern for them. Things change over time, right? And there are many ways to manage that, but ultimately, this still remains a big concern of the cloud usage and how actually to control that and make sure that it remains under the limits that the company has set. And what we have discussed during that webinar, which is why public cloud is on the way out. So if you look at BrightTalk and you search for that webinar, why public cloud is on the way out, what we discussed during that session was that definitely cost management was important, because we know that there is that tipping point of when CapEx, in terms of the way that you are investing in your IT infrastructure, is going to be better than the OpEx way of consuming resources, cloud resources. And even the cloud providers are giving you the option of doing CapEx, right? By managing reserved instances, for example, and making sure that you are able to pay upfront some of the resources that you are going to use to get better pricing and discounts. So basically, this is where you have that curve of OpEx for small environments is definitely better. But as you grow your cloud usage and infrastructure, you have that tipping point where CapEx ultimately is better, because you would have negotiated better with your different providers. We also discussed about whether you really needed less staff. And ultimately, I don't think that you need less staff when you're using public clouds. You are using your staff differently, but definitely not less staff, because you have a lot of new skills to acquire, and that's also a concern for many organizations, because it's not only about having these skilled staff, but it's also about retaining these skilled staff, right? So that's a big challenge, and you don't really have straightforward answers to this. Egress cost. This is something that is a very typical concern when it comes to public cloud. The model is made to have you put your data into these environments, but not really to get them out, because you have excessive costing attached to the fact of removing data out of public clouds, right? So you need to improve that part. You definitely need to have better data governance to know which data you want to put on public clouds and which you need to put or remain in your private environments, right? And all of this, why we are talking about cost management, is basically to manage your margin. And the reason this is important is basically because we showed in that session that you have a one-to-one mapping, between your margin and your market capitalization. Okay. The last element that we have seen, and this is where the rest of the session will be looking at, is reversibility, right? That's why we are talking about application mobility, is simply because you need to be able to have that reversibility capability. And if you look at the different pillars, for example, from AWS well-architected framework, this is something which is missing. You have operational excellence, security, reliability, performance, cost optimization, and recently sustainability. These are all very important pillars and definitely need to be used to properly architect your workloads on not only AWS, but various environments, right? So you have things that are just good practice, I would say. But you do miss that reversibility capability, and that's normal. Many of these providers don't want you to move around their competitors, but basically get you locked into these environments, right? And that's what basically all the application mobility is about. How are you guaranteed that you can move your application from one environment to the other environment without a lot of development / integration overhead? Okay. And for that, the solution is Kubernetes, right? Why? Because I typically consider Kubernetes as a cloud operating system. You have various ways of consuming the cloud, but ultimately, today, the only way or proper way to be able to use these cloud resources in an agnostic manner and not be locked into what these providers are providing is to use Kubernetes, right? So the same that we had with Linux as being that open source operating system, we can see the same as Kubernetes being able to be run on various environments, whether it is Google Cloud, AWS, Azure, on-prem with Nutanix or VMware, OpenStack, and even bare metal environments, right? So you can run Kubernetes everywhere. And you can run the same Kubernetes distribution everywhere, right? And you will have the same set of APIs provided across all these different environments that will allow you to deploy your applications and integrate your application with various services using the same way of packaging your application, the same way of deploying your application, and the same way of configuring your application, right? So the day one and day two is then similar across all your different environments. And that's something which is very, very powerful, because in that case, you do not need, for example, when you want to move from AWS to Azure, for example, you do not need to rebuild your application completely or repackage your application, right? Moving from VMware VMDK, for example, to AWS EC2, this is a process. You need to repackage your application. You need to unpack your VMDK archive, repackage that VMDK archive to be able to be compatible with EC2, and then upload that EC2 instance into AWS, and then start the virtual machine and make sure that it works, right? So that's a process, and if you have to do, or you need to do that for multiple applications, tens, hundreds, thousands of applications, then this is a migration process. With Kubernetes, this is not the case, because once you have moved your application into containers and you have developed the proper packaging tooling to deploy and manage your application, then you can do that across various environments. Okay. But what is a good Kubernetes cluster? Kubernetes is complex. This is a reality, and Kubernetes is getting more and more complex when you look at what it used to be a couple of years ago and what it is today, and all the different things that is gravitating around Kubernetes. Kubernetes can be seen as something which is very, very complex. And some of the organizations I do talk to do share that concern and say that, one, they don't have enough, again, people or skills to manage Kubernetes, and basically this is holding them back instead of allowing them to accelerate, right? So this is a reality, and we do today have proper mechanism to kind of reduce that overhead, right? And as Kelsey Hatta was saying, yes, you need to invest into CI/CD pipeline. You need to invest into infrastructure as code. You need to invest into automation, basically, right? To make sure that as many things are automated, not only on the application layer, but also on the containerization Kubernetes layer, right? And we will be looking at all these automated procedures in the next slides. So what do we need then to do a proper Kubernetes platform? We know that we need to improve the go-to-market, right? So we need to make sure that the platform is consumable by dev and by ops teams / security teams, right? To be able to deploy applications quicker than in the past, right? If we look at VMs, we had our code, we were building the application, right? Compiling the application, packaging the application, installing that in an operating system, packaging the operating system, and then deploying the operating system, right? So that was, again, a process that was automated with proper CI/CD principles. With containerization, it is something which kind of is similar, different tooling, but it is similar. But again, the key element is CI/CD to automate the deployment process. Security is job zero. That has not changed because of Kubernetes. Before Kubernetes and after Kubernetes, you will always need to make sure that you are making the proper blockers in your application that will prevent any issues. That's one thing. You will always need to have proper tooling that will allow you to make sure that you are not exposed to any threats, and you will always need to protect the various components of your system, not only the application but the virtual machine, the operating system, the network, etc., etc. Right. So security is always something that will need to be addressed. Central point of collaboration, and for that you need various dashboards, whether it is for logging, monitoring, and alerting, but you also need dashboards to manage the infrastructure. You need that dashboards to deploy and manage the applications that you are deploying, etc., etc. Right. So having the central point of collaboration is also something which is important, simply because it also improves the operational excellence. Flexibility, and this is related to deploying faster the applications, but also this is related to having multi-cloud. And why you need multi-cloud is because this allows you not to be locked into one single provider, right? So you will be using the best platform based on your requirements, but you will also be able to use the best platform based on costing variations or costing improvements or optimization. Future-proofing then is also, you are using that platform today, you are using it in a multi or hybrid cloud environment, but you definitely need to look also at the future, right? So which components will be integrated, how it will be integrated, and you have that freedom of also integrating properly these different components based on the workload roadmap, right? So basically, do you have the freedom of selecting these plugins or selecting these components compared to what someone will be proposing, and you don't have any control on that roadmap, right? So future-proofing is also something which is very, very key. So this is basically how we in Mirantis we do it. The automation piece. We have part of it which is related to the cloud. So we automate a couple of things around Kubernetes itself and how we deploy and manage that on top of clouds. But we also have the automation around applications, right? And these are the two key components, as I said. We call that ZeroOps in our documentation, right? But ultimately, what I want to share here is, as I said, you are going to need automation. That's going to be very, very key, right? You will need automation because this is how you're going to be successful with Kubernetes. Why you need Kubernetes? Kubernetes is the cloud operating system. So let's say that's now something that you have selected. Once you have selected that, you will need to put in place the proper automation, not only around handling Kubernetes, but also around applications, right? So for that, for example, as an example, right? We in Mirantis, we would be using various components to do that. Here I'm showing an example of how to leverage Terraform and some specific providers that we have built within Terraform to do Kubernetes as a service, right? So this is a reference design where in a couple of minutes, we are able to deploy the full stack. We are able to deploy the runtime. We are able to deploy the Kubernetes engine, and we are able to deploy the private registry along the logging, monitoring, and alerting stack, right? And all of this is handled by infrastructure as code. So we have Terraform as the infrastructure as code component. Then, so all the different templates in Terraform. Then within these Terraform templates, we have specific providers, and we use these specific providers to deploy and configure MKE for the Kubernetes engine, MCR for the runtime, and MSR for the private registry. And we can do that across different environments. Can be on bare metal, can be on Nutanix, can be on Azure, or can be on GCP, right? So here we are automating the capability to do Kubernetes as a service. And again, this is very, very key, right? Another approach of this is, and this is part of Mirantis open source innovation strategy. During the past year, I had a couple of webinars around a component which is called K0s Motron. So K0s Motron is a component that Mirantis has developed and open sourced around July 2023. And the idea behind K0s Motron is to be able to do automation around Kubernetes as a service by leveraging the capability to put Kubernetes control plane components into pods, Kubernetes pods, right? So basically, you would have a first instance, which we call the management cluster. This is a Kubernetes cluster. And then you will have all your different Kubernetes clusters that we would name child clusters, right? So these are the clusters that you would use to onboard your applications and serve the different serve your different users, okay, with these child clusters. And what we would typically do with K0s Motron is the control plane of these child clusters would sit as pods within the management cluster, right? So that's the default way of how K0s Motron works. We will be providing a new iteration of K0s Motron in the coming weeks, where the control plane will also be able to be deployed in dedicated nodes, as would some very standard Kubernetes as a service manager would do today, right? So you have your management cluster and you are deploying your different child clusters, and you have your control plane in dedicated nodes, virtual or physical nodes. So that's coming also in K0s Motron. But today, in the standard approach, preferred approach, we are managing these control plane components as pods within the management cluster, right? The advantage of doing that is, one, you have automation, and how you have automation is the integration of CAPI with K0s Motron. So that's very, very key, because in that case, you can leverage the CAPI component to do Kubernetes as a service. You define your CAPI templates, and then you call the Kubernetes API, and you have your different child clusters deployed. And the interesting part about CAPI is that you have an integration with various environments, right? You have CAPI for OpenStack, which is called Capo. You have CAPI for VMware, which is called CAPV. You have CAPI for AWS, Kappa, CAPI for Azure, CAPZ, etc., right? So you have all these different integrations that can then be made with the management cluster and K0s Motron, and you can then do Kubernetes as a service for your child clusters using these infrastructure as code approach or concept, right? So that's a very, very important and key element for the automation of your child clusters. Again, this is something that will happen within a couple of minutes, right? The time it takes to just spin up the virtual machines and then install the operating system with the proper template, and then or deploy the operating system with the proper template, and then deploy the Kubernetes distribution. In this case, with K0s Motron, this is K0s, which is also an open source Kubernetes distribution coming from Mirantis innovation team. So we talk about the Kubernetes as a service automation here, right? Very important step to be successful with Kubernetes. But what about the rest of the services, right? Because we say cloud and not Kubernetes. We said, how can we do application mobility? And the key element of why we need Kubernetes is that it is a cloud operating system, right? So cloud is an important word here. So it's not only about Kubernetes, but it's cloud, and cloud you have various services. And the good thing is, again, you can leverage open source components to kind of automate the integration and deployment and integration of various components within Kubernetes, right? You would be using GitOps approach. Within the GitOps approach, you would have your source of truth. And from that source of truth, you can design various strategies to deploy the different components across the different Kubernetes clusters running in different environments, right? Whether they are on public cloud or they are on private environments or private clouds. In that example, for example, I have a strategy where I have two layers. A first layer, which is a common layer, and a second layer, which is a per cluster customization, right? So how do I do that? Is I use Git as my source of truth. I integrate that with Flux CD, for example, or Argo CD. And within my different Flux CD, my Helm charts that I'm managing in the Git repository, deploying the different Helm charts, some of them across as being in the common layer across all the different clusters. So let's say I'm running Mirantis Kubernetes engine in various environments, but I'm also running some EKS, also running some AKS, etc., right? So I have all these different Kubernetes clusters, different technology that I'm running across different environments. I can make sure that all these different clusters will be running the same components defining the common layer. This is typically related to security, for example, right? So let's say I want to deploy Privy to scan the images in my cluster, or I want to deploy Falco for event monitoring and management in my different cluster, right? And this is mandatory because I want to be able to make sure that across all my different clusters, I am able to monitor all the different events and make actions on these events. And I want to scan the different images that I'm running in production across all these different environments, right? So you would have these definitions set in the common layer. And when you deploy these different clusters and you enforce the continuous delivery pipeline, or you use or trigger the continuous delivery pipeline, then these components defined or configured in the common layer will be deployed across all these different components, right? And then you can also say that on a second layer, then I have a per cluster customization. And in that case, what that means is that you can dedicate some very specific customization or very specific component to be deployed in dedicated or specific Kubernetes clusters. Let's like for example, in the EKS one, you want to deploy Multus, for example, right? And why you need Multus is because simply you are going to run workloads that requires multiple network interfaces in this cluster. But you don't need Multus in the vanilla Kubernetes, right? So you don't need to deploy that. So that's why it's not in the common layer, right? So you have this approach that you will be able to enforce using GitOps and continuous delivery components, right? We, for example, in Mirantis, we have a product which is called Autopilot, and that's exactly what we are doing. With Autopilot, where we leverage GitOps with Flux CD or Argo CD, we are able to define the deployment of various components for logging, monitoring, and alerting, for networking, for security, and for CI/CD across all major Kubernetes distributions across different environments, right? So we are not locking the deployment on only Mirantis Kubernetes engine, but you can deploy all these components on, let's say, OpenShift or EKS or AKS, and across also on top of various operating systems. Again, it's not related only to Red Hat Enterprise or SUSE. You can use any of the Linux operating system mainly, and deploy these different components to leverage, to automate the capability for you to extend your Kubernetes capabilities, right? So that's step one. You have automated Kubernetes with either infrastructure as code using Terraform or something similar, or using Capi, and I gave an example with K0s Merchant. So now you have your Kubernetes cluster. Step two, you want to automate the capability to deploy plugins in your Kubernetes cluster to help or to act as helpers for your applications, right? And for that, you are going to leverage continuous delivery components. You can use also Kubernetes to serve major services that is required by your application, like, for example, database as a service. In this example, what I'm showing is that you are running multiple Kubernetes clusters across, in maybe one single tenant, or in multiple tenants, or one single cluster, or multiple clusters, right, depending on which environment that you're using. You would be running your application in this one, right? So as an example, this is where you have your application running. But your application needs to interact with databases. So for that, you can dedicate a Kubernetes cluster. In this example, I've deployed that on Mirantis Kubernetes engine, and I'm leveraging a partner of Mirantis, which is Portworx, right? So I'm using Portworx Enterprise solution, and by using Portworx Enterprise solution, I'm integrating the capability to deploy databases, various databases like SQL databases, Redis, Kafka, right? You have all these different databases that can be deployed on top of Kubernetes using the Portworx SaaS offering. Okay, so I deploy my databases on the dedicated Kubernetes cluster, and I serve these databases using a standard way of exposing services on top of Kubernetes, right? Like, for example, I expose these services using a service object load balancer type, and I can configure the service object to use proper IP configuration of the load balancer, right? So in this case, as I am doing that on top of OpenStack, for example, I'm asking Octavia not to expose that using external public IPs, but to do that using only internal tenant IP, right, with the proper annotation. And once I have exposed my database service properly with the proper security setup, like microsegmentation and firewall rules, then this load balancer will expose my different database instances with that IP or URL, depending of how I want to expose this service, because you also have some resolver services in the OpenStack Cloud, for example, and your application can then connect to these databases using this IP, right? So that's just an example of how you will be able to continue to leverage Kubernetes to also manage components like databases that you are getting from clouds that you would need on these environments, right? So you don't need also then to get again and locked into using some solutions that will be difficult for you to port to other platforms, but you can again use Kubernetes to host these services, which you will be able then to port from one environment to the other, right? The same for object storage. For that, we typically use Minio, for example. We deploy Minio on top of Kubernetes, and then we serve the different buckets using standard ways of exposing services with Minio, and then application can then connect with these HTTP, HTTPS services, right? This is just some of the examples of services that you will be able to serve with Kubernetes. And again, this is related to application portability, because once you want to migrate or port your application from a given environment to another, then you need to port this one, you need to port this one, and you need to port this one, but they are all running on Kubernetes, right? So they can then be directly ported. Obviously, there is an element of data to be migrated, but that's always the case, right? Whenever you are going to talk about application mobility, when it is stateless applications, very, very easy, and even more easy with Kubernetes, definitely. But when it comes to stateful applications where you have data, persistent data that are stored, then you need to also consider how you are going to migrate that data, right? And this is where data governance is very, very important, of where you are going to host the data so that you don't get into a locked-in situation. What about legacy, right? So how because you will have also your legacy applications running in today, like, for example, VMware virtual machines, and very difficult to port, very difficult to move around different environments, right? So what do you need to do with these applications, and how to rapidly migrate them? And for that, I had a few webinars this year where I explained an approach which in Mirantis we called Application Modernization and Migration Platform, right? AMMP. And AMMP is a product that we use to actually run through the full migration phases, so lift and shift of applications from a legacy platform where you are running your application in either virtual machines or physical machines, servers, and you move them to Kubernetes. So basically you have containerized these applications and then you are deploying these into Kubernetes, right? So what are the big steps to do that? So the first step is I need to assess my application portfolio, right? So we use the tool to connect to a pool of resources, virtual machines, and physical machines, right? So we connect with let's say, for example, SSH on Linux machine and WinRM on Windows machine, and we do a full scan of these applications, right? So we have a list of applications or runtimes or exec files that we'll be looking for. And we do the scanning of these nodes in an automated manner. Obviously, you can change that list of runtimes execs that you're looking for. You can add or remove some of these of these applications from that list. Basically, if you know that you are running only Java applications, you don't need to bother with .NET, for example. So you can remove .NET from that list, and we'll only scan for and look for Java applications, right? So we do the scanning of these applications. We do a deep scanning of these applications. What I mean by deep scanning of these applications is we just look at what are the configuration files attached to that application. What are the resources that are defined for that application, when they are defined, what are the dependencies that are attached to that application, what are the privileges that are attached to it, right? So we do that deep analysis, and this is what we call the application X-ray, right? At no point we need to have the source code. So we are doing that in the machines, virtual machines and physical machines that are running these applications. But we don't need the source code, right? So there's no intelligence that we are looking into, an IP that we will be looking at, right? So that remains under your control. We only look at the running processes and have some and try to map what we need and what we would need to do to migrate these and put them into containers, right? So out of that assessment step, we are building reports, right? And that's what we call the intelligent recommendations. So we'll be looking at all these different applications. We'll be building these reports, some of them for decision makers, some of them for the technical teams. And basically, we'll be providing recommendations from what we have analyzed, right? So like, do you need to migrate these applications? Yes or no? If no, then we would recommend either to retain these applications or retire these applications, right? But if you are going to reinvest into into migrating these applications or transforming these applications, then we will also provide a rank or a note to these applications to be migrated, and give a ranking on the complexity of migrating these applications, right? So you have in these intelligent recommendations the cost of migrating these applications in terms of complexity and time, and whether then this is interesting or not to move. So either retain or retire or reinvest in migrating them, right? So this is what we have in the rationalization step, right? So we look at these intelligent recommendations, and from there we can decide whether we want to retire or retain these applications, or we want to reinvest into these applications. And in this case, as I said, this is a lift and shift approach, right? We are not looking at your source code, so we are not refactoring the application. We are just taking these applications. We are refactoring these. We are rehosting or replatforming these applications, with a lift and shift approach. So we take them, we repackage them, and we deploy them in Kubernetes, right? And as from there, we start the process of migration. So what we have in that process is we have the transform step, where we take the binaries from the virtual machines or physical machines. We take the various binaries, execs. We take the dependencies. We take the config files, and then we download the archive. We build the Docker file, and from there we create the container, right, with the proper operating system layers containing the dependencies, the application, and the proper configuration to deploy or to start the application, right? So that's in the transform step. Then the second step is we build the blueprint to deploy that application, right? So the blueprint is the main artifact that will be used to indicate how we want to use the newly built container image. So we have the container image. Container image is now stored or saved in a registry. And the blueprint will download or indicate where to download that container image, and also what are the requirements to deploy that container, right? So do you need a config map? Do you need secrets? Do you need to expose it using services? Which type of services? Do you need persistent volumes? Which CSI needs to be, or storage class needs to be used, etc., right? So this is what will be defined in the blueprint. And then ultimately, we will be using that blueprint to deploy the application in the target environment, right? Why we have an iterate step is simply because once we have deployed, we do the test. If something is not right, we move back towards the first step, which is transform. We change the Docker files. We readapt the blueprints, and then we redeploy until we are satisfied with the migration, meaning we have a parity in terms of how we are serving the services from the legacy world, VMs and physical machines, compared to how we are serving the services now in Kubernetes, right? And this is either can be fully automated or semi-automated, simply because, and why I'm saying semi-automated is simply because you have these guardrails, right? You can look at the, stop the process at the build and look at the Docker file. Stop the process at the blueprint and look at the blueprint file, and stop the process at the deploy and do the testing, right? So you have these guardrails that can be used to make sure that the process is going well and you're properly migrating your applications. Okay. Here is a list of applications that can be migrated with the tool. So we support various operating systems, whether they are based on Linux, whether they are from Windows, various versions of Windows, and AIX operating system. And then we have different technological stack that we would support, Java, middlewares, Windows stack, various other runtimes like Python, Ruby on Rails, Go, Bash scripts, C and C++ binaries, right? So various stacks. And all of these, this is why you have this AM, application modernization and migration platform. All of these would be migrated automatically through the different steps that I showed in the previous slide. Databases, typically this is not something that we would touch with the tool, simply because these database technologies come themselves with their own backup, recovery, migration mechanism, and we would typically leverage these mechanisms or features from what the database is providing, and we would be doing that through services engagement, right? Or the customer could still do it using their own teams. We looked at Kubernetes as a service, how we do that with infrastructure as code, various approaches, Terraform, Capi. We looked at how we can automate the deployment of plugins, tooling, extensions, services on top of Kubernetes with GitOps and continuous delivery tooling, and why this was important for application mobility. We looked at how to migrate legacy applications. We need also then to complement that migration of legacy applications. We need to start to look at how to build the pipeline for containerized applications, right? And this is what we typically in Mirantis we call the secure supply chain. And in the secure supply chain, we go through the steps that I showed here, where we are building step 1, we are signing step 2, we are sharing the container step 3, and then we are scanning the container step 4, right? So we have these big 4 steps to properly do a supply chain, but it's not only a container supply chain, it's a secure supply chain, right? And we are adding that security component into this. And it complements what I showed in the migration procedure. Because in the migration procedure, we are moving from virtual machines, physical machines, into containers, right? But you still need ultimately to put in place that secure supply chain to continuously then sign your image, scan your image, and push your image into production. And what you have in this secure supply chain are the big 4 steps that I indicated, right? So you move your code, you are a developer, you're handling your code, and as from there, you're going to build your container image using automation provided by your continuous integration and continuous delivery tooling, right? Once you have built your container image, you will sign that image. And for that, you will use your runtime and you will sign that image with your private key, right? So that image is now signed with your private key. Once that image is signed with your private key, you will store that image into the registry, and you will be also handling the keys of that signed image in your registry, right? Once you have stored that signed image in your registry, you can then enforce automation in your container registry to verify that images are signed and to start to scan images to look for security vulnerabilities, right? So you would continuously then scan the images that you're pushing into your registry to make sure that you don't have known security vulnerabilities. And if you do detect these known security vulnerabilities, then you can decide not to promote your image from, let's say, QA dev environment towards a production environment, right? You will keep it in dev environment. You will reiterate, and you will move back to the development process or step where you would be checking these CVEs, making the proper modifications and integration, updating the different libraries that are required to be updated, changing code where code needs to be changed, and then you go back into the process of building your image, signing your image, pushing the image into the registry, and doing again the verification of the signature and scanning of the image to make sure that there are no critical major CVEs that are identified, right? And then once you are satisfied with the results of the scan, you can promote the image from QA towards production. Once the image is promoted into production, then you can run that into a production Kubernetes runtime. So you would be running the Docker image, signed Docker image into your production environment. Again, this will all be automated by proper CD pipelines. And in your Kubernetes cluster, you can then enforce the signature that you have used at development time, right? So basically, you would indicate to your cluster to check the signature and to only authorize signed images. And that's very, very important, because in that case, you can make sure that only signed images are running in your production environment. And if a container image is being executed in your production Kubernetes cluster that is not signed, then the engine will refuse to execute it, right? And that's very, very key in your automation process. So you have started by signing the image, storing, scanning, and then you have that automation in the Kubernetes cluster that makes sure that you are only running signed images, right? And that's what we typically in Mirantis call the secure supply chain for containers, right? For that, we use Mirantis Kubernetes engine in combination with Mirantis secure registry and Mirantis container runtime. Mirantis container runtime will be responsible of signing the image and verifying that the image is properly signed. Registry will be responsible of scanning and promoting the image from one environment to the other. And as Kubernetes engine is relying on the engine, Kubernetes engine will be able to check through the engine the signature and allow the image to run in the Kubernetes cluster, right? So all of these are then automated through APIs using the proper CI/CD pipelines. And if we look at a real project, yeah, this is interesting because through automation, as I said, right, we are using automation to be successful in using Kubernetes. And we are going to use Kubernetes because we want to be able not only to use or have modern applications, but also to guarantee mobility of these applications, right? So this is a real life example of how we, within 12 months, we migrated applications from a legacy platform running applications running in VMware here, 7 applications running in VMware, and how within 12 months we migrated these applications from the virtual machine world into the container world, right? So 3 months of assessment where we were building these automated reports and giving the proper recommendations. Then we had 2 steps in parallel. The first step was we started to containerize these applications. So we went into the loop of taking these virtual machines and putting them into containers by building the proper Dockerfile artifacts, blueprints, and then starting to deploy them into Kubernetes. And obviously, in parallel, we had to start to build these Kubernetes clusters and build the automation secure pipeline so that the workloads would be able to be properly signed and deployed on top of the platform, right? So all of this goes and then works in parallel. By doing that through automation, we saved a lot of human hours. I think for this project, that was around 20,000 human hours. And we were able to migrate these 600% time faster than if we were to do it manually, right? Obviously, now, as these workloads are now running in Kubernetes, we won't need to have 12 months to migrate them or move them towards another Kubernetes cluster because you already have these artifacts now ready. So if we were tomorrow to move them towards another environment, so let's say they don't want to use their on-prem environment anymore, but they want to move that towards public cloud, then they would deploy Kubernetes there, and the applications would be able to be moved towards that Kubernetes cluster in definitely less than 12 months, right? Because again, you're moving these Kubernetes workloads from a given Kubernetes cluster to another Kubernetes cluster. With that small asterisk, which is we always need to take care of the data migration, right? And this is a key element, key point. If you have persistent data, then you will always have that project, whichever solution or whichever layer or environments that you're using, you will always need to take into consideration the time that it will need to migrate data from an environment to another, right? And Kubernetes is not solving that in particular as any other technologies, right? Simply because you are storing that data somewhere on a given I would say physical environment. All right, so the last step is then the refactor of the applications. So we looked at legacy, how we automated that and moved that into Kubernetes. We looked at how we did the secure supply chain. So now the last step is basically we have access to the source code of some applications that we want to refactor and make them more modern to take benefit of Kubernetes, basically. And for that case, then we would need to cherry pick the applications that we want to refactor, look at the source code, and start to look at how we can rebuild them, refactor the code to make them into more microservices, right? That's a very, very classic approach. We have multiple frameworks that can be used to do that. That can be the open model framework, open application model framework. That can be the 12-factor framework that can be used to properly migrate your application from a monolithic application towards microservices, right? Knowing that microservices is not always the right solution. It all depends on the application properties and also how your team is organized to kind of manage that, right? We've seen and we had example of organizations that decided to move back from microservices into monolithic applications simply because the organization was not able to handle all these different microservices in an efficient way, right? So microservices is not always the right way, but it's the different architects within these teams that would make the best judgment of how to properly organize these applications to make sure that they are leveraging the proper services from the different environments, right? But we in Mirantis, we also have an very interesting approach around that. Here again, we leverage and we contribute to a project called Lagoon, right? So Lagoon is an open source project that we contribute massively. And the interesting part about Lagoon is that it allows developers to concentrate on their code and not to take care of the platform on which the code will be running, and also how the application needs to be packaged to run on this platform, right? So for that, we have the various steps that are used within Lagoon, where a developer will be again concentrating on coding and pushing the code towards the Git repository. So that's step one, right? So step one, developers, they are concentrated on doing the code and pushing it to the Git repository. As from there, you have Lagoon that will start to automate all the different steps, right? So the first step that Lagoon will be doing is get information from the repository, the Git repository in this case, about the new code. And as from there, it will start to package the application, right? So basically, it will interact with the Lagoon remote instance running in the Kubernetes cluster, and it will start to clone the code, source code. It will start to analyze the source code, build the images, create the artifacts around the Kubernetes objects, and deploy the application in the running Kubernetes cluster, right? So the developer is not needing to manage all that. Obviously, the developer can tweak Lagoon to make sure that the code does not go on production first, but would go on a staging environment, and then the test QA team will be able to test the application there, and then give a go. And once the QA team gives a go, then a new event can be sent to the Git repository, and then Lagoon will take into consideration that event and then decide to promote that application into production, right? So you have these different strategies that you can put in place into Lagoon. So then Lagoon, once the deployment is done, the Lagoon will push back the notifications towards the user, and as from there, the user can start to use the application, right? So it looks like a CD component. So you have some similarities with CD components, but the big difference with CD components is that it also takes care of the cluster, Kubernetes cluster, on which the application is running, right? So that's very, very important, because in this case you have these two big steps that are done. You have the application handling, and you have the Kubernetes cluster handling, right? And for that, you have AMMP.io, which is part of Mirantis, and this is what the big difference between AMMP.io and Lagoon. Lagoon being the open source project that we contribute to, and AMMP.io is being the SaaS offering that Mirantis provides, that will allow users to easily consume Lagoon, right? So basically, in this case, developers will be concentrating on their code, will be using the AMMP.io platform, SaaS platform that is managed by Mirantis. And as from there, Mirantis will be taking care of the underlying infrastructure, packaging of the application, and run of these applications, right? Ultimately, of course, the developer is always in control of the application, so we'll always be able to stop the application or the run of the application and all, right? So that remains under the control of the developer or the operational team on the customer side. But a lot of the build run is being handled by AMMP. Okay. And as a summary, what I wanted to share is that, again, automation is very, very key, right? So we looked at why we had to, or for application mobility, right? We were selecting Kubernetes being open source, Kubernetes being that cloud operating system. But as being complex, as you have a lot of moving parts around Kubernetes, automation is very, very key. Automation is key with the way that you are deploying Kubernetes clusters. So Kubernetes as a service with infrastructure as code approach, Terraform, Ansible, Capi, right? And you have options in the open source world. Once you have automated that, you need to automate the way that you are deploying your services and plugins in Kubernetes. And this is where you have CD tooling, continuous delivery tooling like Argo CD and Flux CD to leverage GitOps, right? But you also then need to take care of your applications. And for that, you need to build secure supply chains that will be able then to be integrated with migration pipelines to move your applications, legacy applications from VMs towards containers. But you also then need to refactor some new modern applications, and you have ways of fully automating that process going towards what we call the ZeroOps approach, right? So again, ZeroOps is very, very important because through ZeroOps, you are automating a lot of these steps. And how we help customers, we provide these ZeroOps process, not only on the application layer, but on the platform layer, right? So we are able to address all these different automation requirements for platforms, for Kubernetes, and for also modern applications, right? So that you concentrate on the applications and we do the operations, right? And the guarantees that you have behind that is we are using open source components. You have the reversibility pillar, which is then guaranteed, and you also then can control your cost. Rapidly on if you want to learn more, we have a lot of resources that we have published on our website. So you can go to Mirantis Press, Mirantis blog, or technical talks, and you have more details about the different products, different services, different approaches that I shared today in the webinar. So do not hesitate to look at these resources. We also have a coming webinar, which is very, very exciting and interesting, where we are comparing free open source micro Kubernetes, so K0s versus K3s versus micro K8s. And we are going to give you some hints on how actually to choose these lightweight distributions, right? So this is coming on January 25th next year, 9 a.m. Pacific time, 6 p.m. CET time, and this will be provided by my colleague, Kevin Ning. If you have any comments or suggestions for this session, do not hesitate to contact me. I'm always very happy to have a direct discussion with you, answer your questions. Thank you very much for your time today. I wish you a good rest of your day, afternoon, or evening, and looking forward to see you in the next coming sessions. Thank you. Bye-bye.